system. We're going to move out from the sun, or from the moon, which was video 1, to the sun. And some things that I'd like you to know about the sun aren't like how hot is it or where is it located. It's just at the center of our solar system, creates the biggest dent in our vicinity, and all the planets are just satellites that orbit that thing. That's all gravitational talk. What I want you to know is, where did the sun come from? Where is it for real? A lot of people ask me when they have me in class, do you believe in extraterrestrials? Every star, and there are billions and billions of stars, has the possibility of a solar system rolling around it. Planets just like ours. Just in our galaxy, there's billions of stars. There's also billions of galaxies as we expand out from the sun. So the possibility of there being only one planet with life on it, probably pretty slim. So there's another question though, could they get here and actually visit us? It depends on time travel and all sorts of things we don't understand. So right now we're just going to concentrate on, where is the sun, where did it go, and how did it get here? So the sun is a star. It's no different than any other star. You look up in the sky and you see stars. They're all suns. Some of them have solar systems rolling around them, some of them don't. So a star is a main sequence star if it's just burning. And they can be different heats, different temperatures. There can be blue stars, really hot. There can be red stars, kind of cold. And there can be yellow stars or white stars, which are white are hotter than yellow. Yellow is more like red. And so they can be different colors. When they're different colors, it usually means they're hotter or colder. Now, it can also mean it's moving towards you or away. That's called a red and blue shift. That's typically galaxies that are doing that. So in this particular case, what ends up happening is the star is just burning away, and it's burning fuel. The hydrogen and nitrogen are the hydrogen is smashing into other hydrogen, and it's like a nuclear furnace. It's like nuclear energy. And the star will just burn. Okay, as it starts to run out of that fuel, in other words, maybe the hydrogen on that planet is all starting to smash together and make different atoms at the core, and it starts to lose the energy that it once had. What will happen is that star will start to collapse. Okay, when it starts to collapse, it'll get hot, because the potential energy that was holding it out is now turning into kinetic, and the kinetic energy is heat, and heat energy makes it hot, so then it'll expand again. Now, when it expands, it doesn't quite have the energy to stop it as it did before, so it will enlarge. Then it will start to compress, and it will enlarge, and then it will start to compress. Now, these are red stars. In fact, we call it a red giant in its final phase. Eventually, it'll get gigantic. When our star starts to pulsate and change, we're 3 football fields away. Picture the sun, the size of a goalpost. That red giant will just about take us out. So it will expand from the size of a goalpost out to 3 football fields in diameter. And it will be a red giant. We'll be toast if that happens. We'll be way too close to the sun, and all heck will break loose. And no matter how much we fix pollution, it's not going to help. We're going to be done, not because of what we did, but because of what the sun's going through. So that sun will expand out and become a red giant. Depending on how big the sun was, it will have 3 phases. So it will start as a star. We call it a main sequence star. It will go to a red giant phase. Every star does this, supposedly. We haven't seen all the stars do this, but we've seen these different phases in place. This could take millions of years or hundreds of thousands of years, I don't know. And then the next thing it's going to do is either nova or supernova. When it collapses, boom, all of its energy on the outside is going to get thrown out. If it collapses into about the size of a state or a planet or a country, it goes to the size of, let's say, our moon. We call that a white dwarf. Let's say it goes to the size of our planet. It goes from that goalpost down to a ball. When it's being held up by like a white dwarf, it's not going to have any energy to burn. It's going to be a burnt out star. And when it does that, it's still going to be being held up not by gravity, but by electromagnet repulsion. So it's still going to have a pretty good size to it, and it's going to do that. If it's a bigger red giant and it collapses harder, it will go down to what we call a neutron star. Here it becomes a giant neutron. It's about the size of a city. And if it's doing that, it's going to spin really fast. So it's going to have a lot of rotational energy at that point, just like a pirouetting ice skater. When it collapses down to the size of a city, the only thing holding it up is nuclear energy. And it's going to put off a nuclear pulse. We call them pulsars. Neutron stars, same thing, different name. It's like a giant neutron where nothing's holding it. The particles are like all just hung together. Very, very, very dense material if this happens. If it's a great big star and it collapses, it'll supernova. It'll explode, and pieces of it will fly everywhere. But the main part of the star will shrink not to the size of a planet or a city, but it will shrink to almost nothing. It'll be a great big, very dense material that goes all the way down and makes a great big, what we call a black hole. And it's a very deep, deep pucker. And that's where a black hole comes from. Now, supposedly, our galaxy was a huge star that supernovaed, and the pieces that flew all over created more stars. And at the center of our galaxy is this black hole that created our galaxy. So everything's rolling around just like planets roll around suns. And then those supernova or blow apart into a neutron star, and material goes here and goes there and gets captured by other suns, and this process of blowing up creates new stars, and then they do the same process. So this is pretty much the life of a star, and it doesn't happen once. It happens over and over and over and over and over again. And remember, it has three possible fates: size of a planet, size of a city, or no size at all.